everything you have ever seen, every star, every sunrise, every face, every photograph ever taken of deep space, is built from light. And light, it turns out, only shows you a tiny sliver of what's actually out there. Because around 95% of the universe is completely, utterly invisible, not hidden behind something, not too far away. Invisible, in a way no telescope on Earth or in orbit can ever fix. And here's the twist that unsettles scientists. We know it's there. We've measured it. We've mapped it. We just can't see it. So the real question isn't only what this invisible universe is. It's why we can't see it at all. Let's find out. This isn't a story about things being dark or far away. It's a story about the limits of seeing itself. To understand why most of the universe is invisible, we first have to understand what seeing actually means, and why the entire history of astronomy has depended on one single thing. Then we'll meet the two great invisible components of the cosmos, discover why they refuse to show themselves, and learn the brilliant detective tricks scientists use to find what they cannot see. By the end, you'll understand why a better telescope will never solve this, and why that's one of the most exciting facts in all of science. Let's start with light. Here's the foundation everything rests on. Almost everything humanity knows about the universe, we learned from light. Not just the light your eyes can see, but the entire family of it. Radio waves, infrared, ultraviolet, X-rays, gamma rays. They're all the same thing, electromagnetic radiation, traveling across space. Every telescope ever built is essentially a bucket for collecting some form of this light. When we look at a distant galaxy, we're catching the light it gives off. That's our one and only window onto the cosmos, our single sense as a species peering into the dark. And it's an incredible window, but it has a fatal blind spot, because to be seen through it, an object has to interact with light in some way. And the majority of the universe simply doesn't. This is the crux of it. To see something, light has to do one of three things: bounce off it, be absorbed by it, or be given off by it. A planet reflects sunlight, a star emits its own, a cloud of gas absorbs and glows. But around a quarter of the universe is made of something that does none of these. It doesn't emit light. It doesn't reflect light. It doesn't absorb light. Light just sails straight through it, as though it weren't there at all. We call it dark matter. And dark is slightly misleading, because it isn't black or shadowy. It's transparent to light in every form. You could shine the brightest beam imaginable directly at it and get nothing back. That's why no telescope, on any wavelength, will ever take its picture. So how on earth do we know it exists? Here's the clever part. We can't see dark matter, but we can see what it does. Because while it ignores light completely, it does not ignore gravity. And gravity leaves fingerprints everywhere. Take a spinning galaxy. Based on the matter we can see, its outer stars should orbit slowly and drift away. Instead, they whip around so fast they ought to fly off entirely, unless there's a huge amount of unseen mass holding them in. Add up that hidden mass across the galaxy, and there's far more of it than everything visible combined. We're detecting an invisible thing by the gravitational grip it has on the visible things around it. Like spotting an invisible person by the dente they leave in a sofa cushion. The object stays unseen. Its influence does not. And there's an even more dramatic way it gives itself away. Gravity doesn't just pull on objects, it bends the path of light itself. And this hands us a spectacular tool. When light from a far-off galaxy travels toward us and passes a massive concentration of dark matter, that mass warps the space around it, bending the light into stretched arcs and rings, like a cosmic magnifying glass. By measuring exactly how the light is distorted, astronomers can map where the invisible mass sits and how much there is, even though they can't see a speck of it directly. In some cosmic collisions, scientists have even watched the dark matter and the visible matter separate and drift apart, revealing the invisible component purely by how it bends the starlight behind it. It's detective work of the highest order, mapping a ghost by the shadow it casts on light. But dark matter is only part of the invisible story. The biggest slice of the invisible universe, around 68%, is stranger still, and it's invisible for a completely different reason. Dark energy isn't an object floating in space that simply happens to be transparent. It appears to be a property of space itself, a faint push woven into the very fabric of the cosmos. You can't point a telescope at it, because it isn't located anywhere in particular. It's everywhere, evenly, all at once. We know it exists because of what it's doing to the whole universe, driving galaxies apart and making that expansion accelerate over time. So this part of the invisible universe isn't hiding from our telescopes. It's simply not the kind of thing a telescope could ever be aimed at. We detect it only through its effect on the grandest scale of all, the expansion of everything. Once you know how to look for effects rather than objects, the evidence is overwhelming. The entire large-scale structure of the universe, the great cosmic web of galaxies strung along enormous filaments, was shaped by dark matter's gravity, acting as invisible scaffolding for everything we can see. And the oldest light in existence, the afterglow of the Big Bang, carries a faint pattern of ripples frozen into it. The exact size and spacing of those ripples only makes sense if the universe is filled with the precise amounts of dark matter and dark energy we've calculated. In other words, the invisible universe left its signature on the very first light, a cosmic fingerprint we can still read today. Multiple completely independent lines of evidence all point to the same answer. The invisible majority is real, so why can't we just catch it? Here's the part that surprises people most. We will never solve this with a bigger or sharper telescope, and not because our telescopes aren't good enough. The problem isn't resolution, it's interaction. Telescopes catch light, and these things don't deal in light. So scientists have turned to entirely different methods. Vast detectors buried deep underground, shielded from interference, waiting for an incredibly rare nudge from a passing dark matter particle. Giant surveys mapping millions of galaxies to trace dark energy's push across cosmic time. Particle accelerators trying to create the unseen from scratch. We're not trying to look harder. We're trying to invent whole new ways of sensing a universe our eyes were simply never built to perceive. And that effort is one of the great frontiers of modern science. Step back and it's genuinely humbling. For all of human history, we assumed that what we could see was the universe. Now we know the visible cosmos, every star and galaxy in every photograph, is just the foam on top of a far deeper ocean. Our eyes, and the telescopes that extend them, were only ever tuned to one channel, light. And the universe, it turns out, mostly broadcasts on frequencies we were never equipped to receive. Yet here's the triumph in it. We figured out that an entire invisible universe exists, and measured it to remarkable precision, using nothing but cleverness, gravity, and the faint clues it leaves on the light we can see. We didn't need to see it to find it. So let's bring it together. We see the universe through light, and that's the whole problem. About a quarter of the cosmos is dark matter, which ignores light entirely, betraying itself only through gravity, holding galaxies together, and bending starlight around it. Around 2/3 is dark energy, not an object at all but a property of space, revealed only by the accelerating expansion of everything. Neither can ever be photographed, because neither deals in light, so the universe is 95% invisible, not because it's hidden, but because our one window onto reality was only ever built to catch the smallest part of what's truly out there. If this changed how you see the night sky, or how you think about seeing itself, do me a quick favor. Hit that like button. It really does help these ideas reach more curious minds. Share it with the friend who assumes the stars are all there is. And if you want to keep exploring the universe's deepest mysteries with us, subscribe and ring the bell so you never miss what comes next. Most of reality is still invisible to us, and learning to sense it is one of the greatest adventures we've ever undertaken. Until next time, keep looking up.